So let's look at number 34 in section 5.3. We're going to find the derivative f prime and the original function f. So we're told what the second derivative of the function is. Notice our independent variable is t. So it's t to the negative 3/2 power. And we're given initial conditions on our derivative and the original function. Use symbolic notation and fractions where needed. So that's going to be important in this problem. We'll see in a second. So first, to find f prime, I'm going to find the antiderivative of f double prime, right? Integrate f double prime. So I'm going to integrate t to the negative 3/2. And that's by the power rule, right? So the power rule for integration is if I have t to the n, then the antiderivative is t to the n plus 1 over n plus 1, right? Plus our constant. So in this case, negative 3/2 is n. Adding 1 to negative 3/2 gives me negative 1/2. So it's t to the n plus 1, negative 1/2, divided by n plus 1, negative 1/2, and then plus c. Now, dividing by negative 1/2 is the same as multiplying by the reciprocal, negative 2. And then just to rewrite this in fraction form, right? What does it mean to t to the negative 1/2? It's 1 divided by t to the 1/2, or 1 divided by the square root of t. That's the way I would write this function, this derivative. Now, we do need to find the value of c, and we have initial condition right here. Plug in t is 49, and the derivative then is equal to 2. So when I plug in 49 in for t, I get this. Square root of 49 is 7. And if I add 2/7 to 2, I get 16/7, right? 2 is 14/7 plus 2/7 is 16/7. So that's the value of c. And so here is my derivative, right? Replacing c with 16/7. Now we'll find the original function by integrating the derivative, right? The antiderivative of f prime is f. So I'm going to integrate this function. Notice I'm going to rewrite this to help me with the integration process. 2 divided by the square root of t is 2 over t to the 1/2, or negative 2 times t to the negative 1/2. So that's important because I'm going to use the power rule on that t to the negative 1/2. So the negative 2 comes out, and I add 1 to negative 1/2. That's positive 1/2. And then divided by 1/2 is the same as multiplying by 2. So I'm just going to multiply by 2. So there's the antiderivative of that. 16/7 antiderivative is 16/7 times t. And then plus an arbitrary constant. I'm going to call the constant d, not to confuse it with my constant up above from my first integration. Okay, clean this up. Negative times negative gives me negative 4. T to the 1/2 is just square root of t. And so now I just need to find d from my initial condition. Here was the initial condition from that we were given. So when t is 49, the function will be equal to 5. So I plug in 49 for t here and here. And I'm going to solve for d now. Square root of 49 is 7. 7 times 4 gives 7 times negative 4 gives me negative 28. And then notice 7 divides into 49 7 times. 7 times 16 is 112. So adding those together, I get 84. Subtracting 84 from 5 gives me negative 79. So that's the value of d. And so here's my final function. Okay. So these are a lot of fun. Nice solving these initial value problems. I hope this is helpful.